We're live.
We are live. Hi.
Yay.
I had to go get the ice cubes. Almost forgot them in the freezer.
Right. We're excited. We're going to talk about thermal energy, but before we get started, we'd like to thank our sponsor, Greeley Station, for making this video possible and live broadcasting. If you're tuning in right now on the Greeley Station on the YouTube channel. Later, this will be added to the Colorado Model Railroad Museum's Facebook page. So if you have any questions, you can ask us live today or post them on our Facebook page, and one of us will get back to you. We're very excited that you're here. The mission of the Greeley Station is to provide opportunities to connect amongst business members, individuals, and organizations right through the Greeley Station. Another sponsor I'd like to thank today is HPE, Hewlett-Packard Enterprises out of Fort Collins, who have been kind enough to donate to the youth programs, and which is helping provide the materials and everything else we are using today in our live stream broadcasting.
Yeah, thank you, HPE.
Yes, thank you.
We do appreciate that. So, once again, we're going to talk about energy.
I'm so excited.
And you'll have a PowerPoint that'll come up on the final product so that you can look it up. Types of energy that we've been talking about. What have we been talking about? Solar.
Yes.
Wind.
Static.
Electric.
Bio.
Chemical.
Yeah. Water.
Hydro. Yeah.
Yes. Hydro.
Today we're going to focus on, if you can guess with all the cups and the coffee maker, thermal energy.
Yay! Thermal energy.
Thermal energy. What is thermal energy? Thermal energy is heat energy. So it's when one kind of energy is turned into a heat energy. We call that thermal energy. It's when it goes from like electricity into like a stove, and we'll talk about that again later, and it gets warm, that's your thermal energy. It is produced when there is a rise in temperature.
Which is
right?
caused by
The sun is the most basic producer of thermal energy on our planet. Yeah. Remember we talked about that sunny spot? How come the dog lays in the sunny spot?
It's nice and warm.
It's warm.
And it helps heat the body temperature.
Mm-hmm. Yeah, so how does that work? What happens to make that happen? It's all about molecules. So heat is actually when molecules are moving faster, they get warmer. So if you rub your hands together like this, what happens?
Ooh, I feel it. It's warming, like it's getting warm.
So you're using what? Chemical energy, because you ate food and your body is giving you the ability to move your muscles.
Coffee.
And you're turning chemical energy into, now touch your arm.
Heat. Oh, wow.
Thermal energy.
Wow, look at that. Oh, yeah.
Yeah, so when you play a sport or you're going to go work out or something, what do you do first? Warm up, right? Yeah. Because your body's cold, so you got to get all your muscles moving. So you do the jumping jacks and you do a little workout and you get your molecules moving faster because that gets you warmer.
Yes.
So that's kind of the basis of how all of that works.
So the sun creates the warmth within inside the body, in which you can produce your own thermal energy.
Through motion.
Through motion. Mm-hmm. That is so cool.
So let's talk about what the world would be like without heat. What do you think our world would be like without heat in it?
Almost like at the North Pole. Very cold. Arctic cold.
Could you imagine a shower or a bath without warm water?
No. Not unless it's 120 degrees outside.
I know.
No.
And how would you ever eat pizza the first time? I mean, some people like cold pizza, but it's usually at least heated once.
But nobody likes frozen pizza.
Right.
Not that I know of. Do you like frozen pizza?
No.
I don't
your
like
house
frozen
would
pizza.
be cold all the time. So I just want people to realize how much heat is actually around you and in your home and in our daily environment. There's really heat produced all around us. Yeah. So what is heat transfer? When heat is created, it will move from the warmest surface to the coolest surface that touches it. I think one of the most effective examples is when you have a hot pan on a stove and you go to touch it. What happens? Yikes, right? You pull your hand back. Now, what didn't happen is the coolness of your finger did not transfer to make the pot cooler.
Right.
No, the heat of the pot went to the cooler finger and you get burned.
Oh, so that's a transfer of the heat.
That is a transfer of the heat.
So we get burnt because heat is transferring.
Yeah.
Wow.
Or you feel it's hot.
A little
you
hot,
touch something.
yes. Yeah.
But it doesn't go the other way. It always goes from the hottest to the coolest. Heat transfer. It's just another part of science.
So heat trumps cold. Heat will trump cold.
Mm-hmm.
All right.
We'll go over that. There's a point where things will freeze, but typically
yes.
heat will transfer to the cooler surface.
I don't want to miscommunicate that.
In fact, while we're talking about it, I'm going to do a little bit here. Let's see if we can get this to work. I gotta Keurig, so you gotta reset it every day. I just didn't put the coffee in it, but we're gonna do some hot water.
I got excited about coffee for a minute.
We have to push the button while it goes, I think. Just so you want the hot water.
I don't know how to use
it's gonna work, and then it does it.
There it is.
So what's happening here? There's a power cord, and the power cord is taking energy to the Keurig, right?
Right, from an outlet.
From an outlet.
As we talked about last week. Yes.
Goes through the power cord into the Keurig. The Keurig takes water and uses a heating element to heat the water so that I can have a cup of hot water here. And it takes a minute because it's a Keurig. But it was the best way that I could think of to bring it here into the classroom to show you hot water. So now I'm going to have this cup of hot water. Here, Misty, what do you think about this cup?
Oh, that is warm. Oh my goodness. Now,
That's some warm water,
It is some warm water. Ooh,
yeah,
that warmed my palm. Yes.
So what happened there? Tell me about that heat transfer.
Well, every surface I touched utilized my fingertips where the transfer of the heat from the cup came. I touched it with my palm. Oh yes, that's yeah. Yeah.
Right. So another one to think about is in the summertime when you have an ice cream cone and you're holding that cone, what happens to your ice cream?
It melts. It starts
It
to
melts.
melt.
And the sun will shine on it too. So if you have the sun's thermal energy hitting it and your hand's thermal energy hitting it, your ice cream melts really fast, right?
Yes, yes.
So
a lot of heating elements for,
Yes.
attacking ice cream. Well, not attacking ice cream, but melting ice cream.
So another term that we use when we talk about thermal energy is temperature. And so heat and temperature are not the same thing.
They're not.
Temperature is the measure of heat.
Oh, okay.
So temperature is when something, like if you're making candy in a pot on a stove, you have a kitchen thermometer and it will tell you at a certain temperature, that's when the chemicals are just right in there to make the candy.
Oh.
And so what it's doing is the heat inside the pot is transferring to the thermometer and the thermometer is reading that measurement of heat. So that is temperature.
Wow. That's awesome.
If that makes sense. So,
that does make sense.
Yeah.
Thank you.
now, heat is necessary for all living things. We kind of talked about what it would be like to be cold
Right.
all the time.
And it comes back to the sun.
How does the sun make everything live? Or what would our world do without it?
It would be dark, cold. Yeah.
Right, and nothing could live.
Right.
Because the thermal energy makes the plants grow, and that's how our world lives. So,
One of our viewers, Phil, says he's going to invent ice cream that
doesn't
will
melt.
not melt and that stays cold forever. That's awesome. I look forward to that.
I'm going
Thank
to
you.
try to make hot water again if I didn't mess it up. So, we're going to talk about heat in your home. You have to always start a Keurig like that, don't you?
I don't know how to use a Keurig. This is
I want water.
phenomenal technology to me.
We are trying to dispense some hot water.
I'm an espresso. I'm a latte maker, so
Oh, you don't have a Keurig?
I don't have a Keurig.
Yep.
I have an
this is
espresso
just a cup
machine.
at a time. When you're doing water, you have to hold the button. So, where does heat in your home come from?
Heat from our home. Well, for me, it could be the windows. It could also be our furnace. Yeah.
Right. So, how your furnace works is it takes electrical energy or gas energy.
Right.
And it converts that into a heating element. And that heating element has air pass over it, which heats the air, which passes over that heating element. And then there's usually a fan that will blow that through your home. And then you have all those vents. If you look around your room, you'll probably find a heating vent in every room in your home. That's how your home is heated.
Wow.
There are other ways to do it, but that's pretty much how most homes are today.
Yeah.
So,
So we have a question.
Okay.
We have a viewer who wants to know, can heat be converted to other forms of energy?
I think so.
Yeah.
Mm-hmm.
I think
Yeah, you could take heat and turn it into like the steam energy, pressure.
Yeah.
You like a
The
steam
train.
engine. Right.
Yeah,
how a
steam engine. I'm
works.
sorry. No.
Yeah, the steam locomotive. There are
The big boy, the steam locomotive, Big Boy 4014. Yeah, I'm wearing
heat
that.
can turn into a chemical process too, because that's how you make candy. You have the heat on the burner, which makes the chemical change, which makes the candy. So yeah, your energy is moving from one form to another. Energy, remember, it can't be lost and can't be created. Like it's always there. It just changes form all the time.
It's currency. It's got a current. It's movement.
So-
Energy is awesome.
So where do we see thermal energy in our homes a lot? Maybe breakfast.
Oh, my favorite meal of the day because it involves coffee.
Yep. So let's do another example here.
So today speaking of breakfast, I had toasted cinnamon bread for breakfast this morning, and I thought, well, let's show this off. So I wish we had smell a TV. So I'm gonna push this down, and Michelle's gonna talk a little bit about elements.
Right. So we talked about a heating element in your furnace. You can actually see a mini version of this in your toaster. So if you carefully look down into your toaster, you will see the little red wire. It's red because it's hot. So you'll see it turning red when this toast starts to toast. Do you see it in there?
It's turning red.
That is a heating element. And so that's a really simple way to see that in your home every day when you're making your toast. Can you hand me your coffee cup? We're going to do one more.
Yes, most definitely.
I have to make a little more hot water for our experiment.
Okay. Well, I'm
a
little cold. I'm going to warm up here.
So what about our bodies? Is that a heater?
Well, I think so.
I think so.
I mean, I cuddle with my animal, my precious little Zoe, and I get heat from her. She warms my toes, and yes.
Okay, we got to make one more cup of hot coffee so we can do all of our experiment. We need that much water.
Well,
while we're in the kitchen here, so
right? You don't
improvise.
Yeah. Well, while we're doing this, I want to take a quick moment to say hello to a couple of viewers, Liam in Moses Lake, Washington, and Peyton out of Windsor, Colorado. Really appreciate the feedback and everybody's giving us. So a little shout out. Yeah, this is so much fun. We're enjoying energy.
We are. Okay, so I'm going to move the sun down here. We're going to do experiment number 1 is talking about our body as a heater. And this is super simple. You can just go to your freezer or your fridge if you have an ice dispenser and get a piece of ice. Here, Misty, choose an ice cube.
Oh, I'll take this.
Okay. This is the experiment. You're going to hold that in your hand and see what happens.
It's so cold. It's so cold.
So cold.
So cold. Okay.
So what happens when we do this?
Oh, there's a drip.
Is it look, look, I'm like pouring water out. How come that happened? Why did our ice turn to water?
Because of our heat in our body, the thermal.
That's right.
There's our toast.
There's our toast.
The thermal energy.
That's right.
Okay.
That's
I can't
cold.
take the cold
Put
anymore.
That down. That's the most basic experiment that we could do.
We did not bring hand towels.
I have a towel right here.
Oh, it's okay.
Look at me. I brought a kitchen towel since we're talking about breakfast.
There we go.
Now, our next one that we're going to do, I'm just going to go ahead and pour it out of the
You
cup
brought
here.
a Wednesday towel on a Tuesday.
By the way, we can thank Visit Greeley for our Greeley cups.
Yes, thank you.
And this one, we can thank the World Community Foundation for this coffee cup that we had here at the museum.
I have to tell you, both these cups are in my home, and I do enjoy the warmth of my coffee in them.
So we're going to pour a little bit here. We get the table a little wet.
See my...
Just pour a little bit in there. Pour it into all the different
There goes
kinds.
the ice. It's going to start
Now,
melting.
in your kit, you had one of these, which is styrofoam, and one of these, which is just plastic. And then we're going to pour some in here. Maybe a little more in there. There we go.
Okay.
Okay, so we have a little water in all of these. And one thing you can do first is touch them. Is this one warmer, the plastic, than the glass? Or the...
For me, it's definitely...
Which one's the warmest?
So this one
you
here
have
is
an
the
ice cube
warmest.
in it.
I do have an ice cube in it.
So some different kinds of cups that I did bring today are, we have standard plastic, we have a glass, styrofoam. This is an insulated cup, which is a pretty popular thing you can have in your home right now, especially in the summertime. And then your plastic cup. Now, when I touch this one, it's really hot. When I touch the glass, it's not as hot, but it's still pretty hot. But when I touch this one, it's not hot on my hands. I wonder why that would happen.
Why is that?
It's called insulation.
Yeah.
And so the styrofoam cup does not transfer heat through it as easily as the glass or the plastic.
And this is a good visual of insulation.
Yeah, and this one I thought, it was like the clear version of that. So this one doesn't feel hot either. But now what we're going to do is put an ice cube in each of these.
Okay, we have a question, and I had to look it up. I mean,
Okay.
I looked it up for us just in case you didn't know the answer.
All right,
What's the coldest possible temperature? Do you know the answer to that?
I don't know the answer.
I had
to
to
that.
look it up, so that's why.
Is it liquid nitrogen? There's probably something colder than that.
So what I have found on the World Wide Web is most people are pretty familiar with absolute zero. It's negative 273.15 degrees Celsius, which is negative 459.67 degrees Fahrenheit. It's the lowest possible temperature. So that was a really good question.
That was a really good question.
Learning lots of new things today.
I'm going to put an ice cube. I
Thank
still
you
have
for
some
that.
hot coffee in the coffee cup. Now, what you're going to do is figure out which one melts first. Yours is already gone.
Mine's gone.
Yep.
Yes.
This ice cube is melting fast. This ice cube is like gone.
Is it? Oh, it is. It's that insulation.
That one's gone.
So
this one's going pretty fast.
it is.
And this one's going really fast because of the hot.
And I'm still warming
Now, why
up
would
from
this?
that ice.
Why would this one be the fastest melting?
Why would it not be, or why would
Why
it be?
would it? Why would it melt the ice cube faster than the other ones?
I'm going to say the molecules, I'm sure, that make up the foam cup that are producing heat back into it.
It's not letting heat escape.
Huh?
So the heat is staying in there longer. On this one, the heat is just transferring right out through the plastic and right on out. That's the point of insulation, is it keeps heat in and it keeps cold out. So insulation will keep things at a more constant temperature than your other more conducive to heat or cold substances.
Right.
So if that makes sense. They're pretty much all gone now, aren't they?
It's very fascinating.
Did any of them stay?
We've got just a little bit of that
tiny
one.
in there.
A little tiny bit of that
This
one.
one's gone. So anyway, that's basically what we have for an example of thermal energy. We hope that you enjoyed that today.
Yeah, it's a
Something you can play with at home, and maybe you could make some toast while you're doing this.
yeah, you're gonna have some.
Home science. So
Yes,
fun.
yes. Tune in on Thursday at 1. And we'll Tuesdays and Thursdays 1 o'clock right here on the Greeley Station YouTube channel. And again, within 24 hours, we'll have this uploaded to our Facebook, Colorado Model Railroad Museum. This has been absolutely fun, and the Greeley Station.
And if you enjoyed this, make sure you subscribe and like Greeley Station.
Yeah.
So thank you so much for coming.
Hey, paleontology is not far away, so we're looking forward to that transition. Fossil fuels, energy to paleontology. We'll see you all. Have a good day.
Bye.